Right, today we'll be disassembling an alternator. This particular unit is from a 2000 to 2010 Subaru EJ20, specifically the Forester that we have, but they're all pretty similar. Originally, disassembly guides were available in things like Haynes manuals and that sort of thing, or from the supplier, but as sort of time's gone on and technicians' ability to repair things has lessened, the material that we can get our hands on has lessened, so service manuals aren't quite as readily available as they were previously, but alternator disassembly is similar across the board on all makes and models. Once you sort of know how to pull one apart broadly, then you've got a good idea of how to pull them all apart. We'll be using the tools available to us in the classroom toolboxes. We'll start off with our what's called through bolts. The through bolts are mounted from the front housing to the rear housing. They hold the whole thing together. They are very important, so we'll be removing them. All of these processes are obviously a lot faster with power tools, but you should definitely know how to get the job done with the tools available, rather than resorting to power tools the whole time. It's very easy to damage things with power tools. You've got a lot more nuance and feel with your bare hands. Obviously going to place all of my components in one spot. Right, at the front housing, and using the mounting lugs on the front housing, I'm mounting it in the vise nice and securely. I'm not being stupid, it's only an alloy face. Over cranking it will damage the face, may snap it off. There's no reason for it. Right, now that our through bolts are removed, we need to mark our housings. Obviously there's 4 through bolts. This alternator housing will actually go together in any one of 4 ways, and if it's not located correctly, then obviously it's not going to fit back on the vehicle properly. So taking a punch and a hammer, I'm going to mark each housing in the same position. Nice little taps. We have 2 marks to line up. Sometimes one mark is sort of easy to mistake for another, so we're actually going to make 3 little marks in a little triangle. This is just what I've always done. 3 little marks, that way it's a little bit more distinguishable. I'm still only tapping firmly, I'm not beating the living hell out of it. Right, take 2 screwdrivers. Remember, screwdrivers are not pry bars, but they do turn well. So we're going to take the screwdrivers and place them in the recesses that have been made available by removing our through bolts. So one on the top, one on the bottom, and we're just going to turn the screwdrivers while wiggling slightly. We're not levering because these screwdriver tips will snap. We are just placing them in and twisting them slightly. Once the housing has come apart, we put the screwdrivers away, keeping our tools tidy, and our alternator rear housing will slide free. Alright. Our front housing we can remove from the vise and place on the pulley face down on the bench. Now, looking inside our alternator, we can see the stator that is still mounted within the rear housing. Our stator stator windings come down where they're soldered into our rectifier plate. Our rectifier plate is soldered to our regulator, and you can see the brushes inside the regulator. These components are screwed into the rear housing, so we have one screw in the rectifier and two screws in the regulator. The rectifier also has one stud. That stud is our positive stud, the output stud that comes through this housing, and then has a right angled fitment where it exits the housing. To remove this right angled fitment and allow our rectifier to come out, take our screwdriver and place our housing back within the vise. We take our screwdriver and we just carefully pry off this little back plate. Again, with the screwdriver, a twisting motion rather than a levering motion. Levering will snap the screwdriver. Twisting is what the screwdriver is supposed to do. So one cap, place it on the bench. We now have a 10mm nut holding that stud on. So we'll take our 3/8 ratchet and our 10mm drive and just crack that off. Once it's loose, the nut will be removed. Take our nut, place it on the bench with our parts. Return our tools to the toolbox. So this insulated stud is knurled, so the stud itself is a interference fit. So even though you've got the nut off, this won't come off easily. You can wiggle it, or we can take our hammer and just give it a soft little tap. I'm not hitting it too hard, it's just continuous tapping to work its way loose. Our insulated stud onto the bench. Now our components within our alternator are one bolt less fixed. We still have our two regulator bolts and our one rectifier bolt. Take our number 2 screwdriver, my bad, and with an ample amount of downward force, we're going to give it a quick twist to undo it. The torque required to undo a screw is greatest initially. So the idea is that the screwdriver tip needs to be pushed all the way into the screw, and you need to exert a large amount of torque to get the fixture to break loose. If you just turn it as hard as you can, it's likely that you will strip the Phillips head within here. So to undo the screw, you must put a lot of pressure inward and exert a large amount of initial torque to break it free. If when undoing these screws you don't put enough downward pressure on them and the screwdriver head is allowed to lift, it will strip the drive or strip the Phillips head within this screw. If that happens, don't continue to try and undo it. Stop and ask your tutor for help. The other option or the other practice that is good is to take a screwdriver, ideally an impact screwdriver. Impact screwdrivers have a solid tang all the way through them rather than a plastic mounted tang, which means that when you hit on the end of them, it will transmit the force all the way through. If we give it a couple of taps, not hard enough to shatter our screwdriver, but enough to shock the threads within the screw into releasing a little bit, it may assist in loosening that screw. So again, ample downwards pressure, crack. Alright, that's our 2 regulator screws removed. As you'll notice, our rectifier screw is slightly obscured by the stator itself. If you remove the stator, so all I'm doing is taking my hand and holding the inside of the stator, I'm then pushing with my thumb against this housing and pulling up. That will pull the stator out. If you were rough with it, you're going to damage the stator windings. So ideally, it's just a nice simple twist. I'm using my thumb and my fingers. I'm using my grip to apply force to this rather than pulling with my arm. All we're going to do is lift the stator up slightly and work it away from where the screw is. So our screw has now been revealed. We can take our screwdriver, place it into that screw, obviously, and move our stator just out of the way. Plenty of downward force, twist. As soon as that screw is removed, you can wiggle our components and they will come out. So taking that screw, one thing to notice, this screw is longer than the regulator screws. So our rectifier screw is the long screw, our regulator screws are short. Remove the stator and components. There is an insulator that sits on that regulator that can be removed and placed aside. There is also an insulator on the rectifier itself, but it is held in by the stud of the rectifier. So we will take that stator, we'll place it into the bench. We're going to grip onto these parts of the stator. So open the vise and then slowly close the vise just enough to nip into this housing. We don't want to crush the windings, we just want to nip into this housing. Now our stator is held within the vise. If we were to service our stator or our regulator or rectifier, we would do it from this position. So we would heat up our soldering iron and we would unsolder the rectifier from the stator. We would then unsolder the regulator from the rectifier, and we could test the rectifier and test the regulator. Putting our stator to the side, you can see there's an accumulation of brush dust. So that is the carbon dust from the brushes that is worn. It's accumulated in the base of the bearing housing there. We turn the rear housing over and tap it against the bench. That will come out of that rear housing. So this rear bracket can be cleaned. Wire brushing on the edge is a good idea, as our earth path is through these housings. Obviously this housing bolts to the engine block, but these housings are bolted together, so any difference in our ground will actually create resistance and create issues. So having these cleaned up is a good idea. Originally we would have put this in a sandblasting cabinet and given it a sandblast and then a nice clear coat. It's how a full alternator service was generally done. To remove the bearings from the rotor, which is common practice during the service, this bearing here would be removed. Well, definitely, as you can hear, it's quite rumbly. A bearing puller is placed upon here and the bearing is removed. The same with this front housing. If we remove this front pulley, we can remove the rotor from the front housing, and the front bearing can be replaced. I'll show you how to hold the rotor in the vise. So opening the vise up, what we're intending to do is grip the rotor on two of the opposing claws, as they're called, rotor claws. So putting our rotor in our vise nice and straight. You can see our claw is lining up with the vise face. We're going to tighten the vise up to a reasonable amount. We don't want to crush the rotor. We're then going to take our 24mm socket on our power bar. I'm going to place it on that nut and we're going to see how strong this vise is. The vise itself is not strong enough for this. I'm going to end up tearing it out of the bench, or tearing the rotor of the face. It doesn't have enough purchase on the rotor, so we're not going to carry on with this component, otherwise we're just going to cause undue damage. You can see on the face of the rotor where it has actually started to slip within the vise. Servicing the alternator should not result in additional damage to the alternator. So ideally, if servicing it is going to damage it more, we wouldn't continue. Right, reassembly of the rectifier and regulator. We're just going to place the rectifier within the housing. We need to remember to refit the insulator to the regulator itself. I'm going to take our 2 small screws and drop them down inside the regulator. Do one up, spinning up until it starts to bite, and then again, ample downward pressure, just nip it up. It doesn't need to be so tight that you exert a lot of force into it, but you do need to get used to the pressure required. So downward pressure, nip, nip. I'm going to take the longer of the 3, which is our rectifier screw. Just going to drop it down inside there. A screwdriver. Again, ample downward pressure, nip, nip. Our stator then needs to go back in the same place. If we look at our alternator housing, we can see what's referred to as witness marks. Those witness marks, they line up with these laminations of the stator. Twist it slightly so they line up, and then just give it a nice firm press, and we can see that all our edges have aligned. Alright. Right, when it comes to reassembling our alternator, one of the main things to look out for is our brushes. So our brushes live inside here. They run against the slip ring of the rotor. So there's our rotor slip ring there. Our brushes align with that. That's how power gets from the regulator into the rotor. The regulator obviously applies a regulated amount of power to the rotor, which energizes it. If we were to put this back together as it is, that bearing is obviously the same size as this recess here. It would go through and it would smash our brushes. So forcing our bearing in there would smash these brushes. What we need to do is we need to push our brushes down. You can see they got a spring inside them or underneath them. So what we need to do is we need to take our what's called a brush pin, which is simply a nice rigid pin. Alright, so taking our brush pin, you'll see that there is a small hole below the bearing area in the rear of the alternator. Our brush pin will slide through. You'll feel resistance, that is the brush pin touching the actual brushes. So ideally you're going to take your finger, you're going to press down on the brush, and you're going to slide the brush pin through. If you can't push it down far enough, then we will actually need a right angled pin to press it down. What you can do is you can take an Allen key. We'll take a 2mm Allen key, and obviously the 2mm Allen key has a right angled leg on it. We're going to place our 2mm Allen key in there, and we're going to press the brush down. Pretty easy. So placing our brush pin in the back here. Again, the vise is our friend, so put your housing in the vise, nip it up, brush pin in the back, carefully, taking the Allen key, push the brush up, and we can slide our brush pin in. Alright, so You see in there, our brushes are recessed, our brush pin is holding them down. Easy. Then we're going to take our rotor and we're going to place it on top of the vise. We have two different size holes. They are directly opposite each other, but one is large and unthreaded, one is smaller and threaded. This is the tensioner mount, this is the through bolt mount. The rear housing also has a through bolt mount, which is what we're going to align. So we're going to carefully slide the two together, and again we need to line up our stator with the witness marks in the housing. A little bit of a tweak just to get it around. Now what we're going to do is, using our hands, we're going to grip the whole alternator and we're just going to drop it. Just pick it up about 20 mils off the vise, and we're just tapping it against the vise. We're not dropping it, we still want to be holding it, but we're just tapping it against the vise. What that does is it shocks our alternator back into place. So again, place it back in the vise, take our through bolts, slide our through bolts through into the rear housing. Now we can use our Phillips screwdriver just for a bit of speed. Spin those in there until there's a little bit of resistance, and then we'll stop. Now, as soon as there is resistance, we stop. We're not doing it up tight just yet. Right, not tight, just nip it up. So I'm going to take our 3/8 extension and our 8mm socket. Now, the material the alternator is made out of is quite soft. Aluminium is soft, copper windings are soft, the bearing housings are all soft. If we do one of our through bolts up too tight, so I've tightened up one of the through bolts tight, our rotor will likely touch against the stator. It will become tight to turn because we have done up one of our through bolts too tightly. So ideally, when we are tightening up the 4 through bolts, we want to do them in an alternating pattern. So 1, 2, 3, 4. So we're going to start here, go it up until there is some tension, move diagonally across, do that up until there is some tension, move diagonally across, again until we have some tension, and then to the top right until we have some tension. Our alternator spins freely, so there's no binding within the alternator. We can then go back to the one we started with, give it what I'd call a tweak, diagonally across, tweak, straight across, tweak, and then diagonally across again with the final tweak. Our alternator is tight together and our bearing spins freely. Alright, loosen our vise, turn our alternator over, place it face down on the bench. We need to take our insulated stud, refit that back to the alternator, put our 10mm nut on there, we'll grab our 10mm. May have to start it by hand. Again, everything component wise with the alternator is relatively soft or light duty, so doing up the 10mm on our stud, all we want to do is nip it up. Excess tension will obviously snap things, and we can see that there is a little reserve spot where it all aligns with. Take note of these things, don't just crank it up because you're going to snap it. So a little right plastic cap goes back on the back, clips on. We can remove our our brush pin, retain our brush pin so we don't lose it. Alternator spins up freely, sounds beautiful. Ask your tutor to run it up in your test bench, or however they're going to determine the job has been well done. We can see that our marks that we've put on our housings align. This alternator housing is obviously pretty simple because it can only go one of two ways with regards to the legs. Done.